today we'll complete the rest of this topic. In the previous video, we covered the autoionization of water and we discussed the whole process, like in terms of its endothermic, depends only on the temperature, etc. So at that point, we're going to focus on something. Since we're dealing with water, you have to keep in mind that the concentration of hydronium ion is equal to the concentration of hydroxide ion. In other words, if I want to calculate the pH of water um, at different temperatures, will the pH be the same for all of these temperatures? Let's check this out. So in this example here, I'm going to calculate the pH of water at 0 degrees Celsius and at 25 degrees Celsius. So let's start with the first one here. We just, like from the previous class, we know that the Kw, which is the equilibrium constant of water, is equal to the concentration of H3O plus multiplied by the concentration of like the hydroxide ion. Since the Kw depends on the temperature, its value is not the same at different temperatures. We can see like it increases with increasing the temperature. So at 0 degrees Celsius, the value is equal to 1.14 times 10 to the power negative 15. And just like in water, you have to keep in mind, the concentration of hydronium ion is the same as the hydroxide. So but the two guys in here are equal. So I can replace them by like X for hydronium and X for hydroxide. Since you're multiplying the two x's, you will end up with x squared. And here we have 1.14 times 10 to the power negative 15. In order to calculate the value of x, you have to take the square root for both guys in here, and you will end up with a value of x that equals to 3.38 times 10 to the power negative 8. All right. Now, since the x value here represents the value of OH negative and also the H3O plus, then I can say, since the pOH is the same as the pH, I have to calculate it. It means it equals negative log. Compensate this number in here. So it's going to be 3.38 times 10 to the power negative 8. And the answer is equal to 7.47. So we just noticed that the pH of water at 0 degrees Celsius is equal to 7.7. All right, so we have to just like write this note in here because we want to compare it with the value after calculating the pH at 25 degrees. Okay, so the pH at 0 degrees Celsius is equal to 7.47. Now let's do the same process, but at 25 degrees Celsius, we're going to do the same thing. What's the value of Kw at 25? Kw is equal to concentration of H2O plus multiplied by the concentration of OH negative. Since the two concentrations here are equal, I can say this is x squared, and it's 1 times 10 to the power negative 15. We got it from here, don't forget that. X that equals to 1 times 10 to the power negative 7, which is the same as the concentration of H3O plus and the same as the concentration of OH negative. Now, if I want to calculate the pH, which is the same as the pOH, I have to say negative log the 1 times 10 to the power negative 7, and it equals to 7. Just notice that the pH is equal to 7 at 25 degrees, which means that the pH is decreasing, right? I need you to calculate the pH of water at 40 degrees Celsius and 50 degrees Celsius and just comment your answers in the comment section below. But what do we know about the pH? As we said that when the pH is lower, then it means a more acidic or more H3O plus. Okay, so we just explained that since the process depends on the temperature, as we increase the temperature, which is as like it's endothermic, as we increase the temperature, the reaction will be shifting to form more products, and we have H3O plus, which is a kind, or let's say one of the products. It will be the lower pH. In your opinion, what do you conclude the pH for water at 40 degrees Celsius and 50? will be higher or less than. We have another concept that is really good for you. Okay, if you write the Kw that is equal to the concentration of O plus multiplied by the concentration of OH negative, right? Right. In terms of math, if we just remember that I can take the negative log for H3O plus, I can take the negative log for the OH negative. We know that, right? And I also can take the negative log for the Kw. So if this one here, like since we take the negative log, it's going to be the pH. If we take the log for the OH, it's going to be the POH. Just keep the P is in a small letter. And here is going to be pKw. All right. So if you just do some rules in math, if you know them in algorithms, you have to take the negative log Kw equal to negative log of H3O plus. And just keep in mind, since the process is multiplication between two concentrations, when you use the algorithms, the multiplication is going to be a positive sign. So you have to say plus negative log the concentration of OH negative, right? Right. Let's say that we take this concentration at, let's say, at 25 degrees, which is the default value. So I can say negative log 1 times 10 to the power negative 14. And here it's negative log. And here we have the pH, which is the H3O plus the POH. So if you calculate the answer of the negative log of 10 to the power negative 14, the answer here is 14. So you have to keep in mind the summation of the pH plus the POH at 25 degrees Celsius is equal to 14. And now we just know where the 14 came from. It came from the Kw at that point. So this method actually will help you a lot in your examples. And one more thing to be discussed with you. Yeah, and if you want to change the pKw into Kw, you have to use the antilog, which is 10 to the power negative Kw. For example, if the pKw is equal to 14, in order to change it to Kw, you have to say it's equal to 10 to the power negative Kw, and you will have it for sure. So it's going to be 10 to the power negative 14, which is the same as like this one in here. Okay. The last rule for the Kw for water today. We can give you an example with a given values of Kws or the pKw. We just noticed that as we increase the temperature, what happened to the values? We noticed that the values of pKw are decreasing. Like, whoops, the Kws have to increase as a result of increasing the temperature. But you have to keep in mind, we have the pKa. So as Kw increases, the pKw will decrease. So based on your table in here, the least pKw will be the highest Kw. Okay? And I want to prove that in terms of the pH. If it's equal to 1, then it means that you have more H3O plus. So it's the same thing.